Hi guys, so in this tutorial I'm going to take up one problem from Codeforces. So the problem is Taavas and Saddas. So what the question is, so you're given a lucky number. A lucky number is such a number which contains only the lucky digits 4 and 7. So this is given in the question. For example, 47 is a lucky number, 744 is a lucky number, this is a lucky number, but these are not because they contain digits other than 4 and 7. So the first lucky number of the series will be 4, the next number will be 7, the next number will be 44, then it will be 47, then it will be 74, and it will be 77, and so on, and this will go on. So what is the input? The input is a lucky number. Suppose you are given the number 774. This is the input, right? And what is the output? Print the index of n. It means we have to print the index of this lucky number. So index of lucky number we have to print. So for example, in this case the index of 74 in the series is, if I start the series from 1 2 3 4 5, so the output for the 74 is 5 because it is the 5th lucky number. Similarly for 77 the output is 6 because it's the 6th lucky number, right? So let us try to figure out how we can solve this question, right? So for example, the input is 77, the output is 6. Yeah. So let me come to the logic of this problem. So suppose you are given a number like this. Let's say we have some number 447, right? Or let's say 7447. So one idea is to find out how many lucky numbers are there which are less than the current number, which are less than this number, current number, right? So you can clearly see this is a 4-digit number. This is a 4-digit, or in any case it is a n-digit number, right? So I can say if I remove the first digit, if I remove the first digit of this series, so all the 3-digit numbers will be lesser than the current number, right? So how many 3-digit numbers are there? So in the first position, so if I want to count 3-digit lucky numbers, so they will be 2 raised to the power 3, because in the first position you can fill it using 2 ways. Again the second position can be filled in 2 ways, third position can be filled in 2 ways, because at every place you can have 2 choices. Either you can place 4 or you can place 7. So there will be 2 raised to the power 3 lucky numbers. Let's remove one more digit from this number. So how many 2-digit numbers are there? Yeah, so it is, we can clearly see there will be 2 raised to the power 2 lucky numbers. So there will be 4 lucky numbers. And we know what these numbers are. Yes. So we know these numbers are nothing but 47, 44, 74 and 77. These are the 2-digit lucky numbers. Yeah. So let me remove another digit. So I know I have only one place left. Here I can place 4 or I can place 7. So how many 1-digit lucky numbers are there? So there are only 2 numbers, 2 raised to the power 1, and these numbers are 4 and 7. So similarly for a number which is having some digits, let's say this number is having x digits. So if I talk about this part, so in this part I will have how many numbers? So I will have 2 raised to the power 1 plus 2 raised to the power 2 plus 2 raised to the power 3 up to 2 raised to the power x minus 1. So these many lucky numbers are there which contain less digits than the current number. So these are the first part of the answer, first part of my answer. And we know this is a geometric progression, so this series can be written like this: 2 into 2 raised to the power x minus 1 minus 1 divided by 2 minus 1 using the formula of GP. So this is my first part of my answer. This answer is not complete because in this case we have skipped all those numbers which are having 4 digits. We have only talked about 3 digit, 2 digit, 1 digit numbers. Now it's important to talk about how many 4 digit lucky numbers are there which are less than the current number, right? So let me take few examples to explain this. Now suppose I have a number like this: 4 4 7. Let me take the number as 4. So now we are trying to find number of 4 digit lucky numbers less than this. Number of 4 digit lucky numbers less than the current number, which is 4444. Now you know, for this position there cannot be any digit which is less than 4. Similarly for this one, similarly for this one, similarly for this one. So there will be 0 numbers, right? Let me take one more example. Let's say the number is something like this: 44 and 47. So how many numbers are possible? So I know there are two numbers possible. One number is 44 4. No, there is only one number possible which is less than the current number. This is because for this 7 we can have a digit less than 7, right? So this digit is 4, so we have one lucky number which is of 4 digits and which is less than the current number, right? So this 1 can be written like this: 1 is 2 raised to the power 0, where 0 is the index of the 7. So 0 denotes index of the 7. Be careful, this is an important thing I am explaining here. So now we have moved 7 to the another place. So I want to figure out how many numbers are there which are less than the current number. Now you know you can replace 7 with a 4. You can always do. See, you cannot make a number bigger from here. What you can do is you can replace this 7 by 4. You can replace it like this. You can place a 4 here, and for the remaining part you can consider all possibilities for the remaining part, because you have removed this digit, you have changed this digit to 4. Now whatever you take at this position will not matter. So this position is now going to have two choices. So I can say the number of lucky numbers less than the current number will be 2. Due to this change, I will get 2 extra numbers, and these numbers will be nothing but 4 4 4 4 and 4 4 4 7, right? So these are the 2 numbers which have been possible by converting this 7 into 4. So index of this 7 is 1. So its contribution to my answer is nothing but 2 raised to the power 1, because for the remaining part we got more choices. Let me take one more example. Let's say the number is 4744. Now I know this 4 cannot be made any smaller, this 4 cannot be made any smaller, but this 7 can be changed to 4. So if I change this 7 to 4, I can have 2 options here and 2 options here. So this This conversion will give me 4 extra numbers. 4 extra numbers, and this is nothing but 2 raised to the power 2. So here I can say the index of the 7 is 2. So by changing this 7, I get more lucky numbers to 4. So these numbers will be nothing but 4, 4, 4, 4, 4, 4, 4, 7, 4, 4, 7, 4, and 4, 4, 7, 7. So these are the numbers which have been formed by replacing this digit which was earlier 7. So these extra numbers have been formed. So let's try one more example. Let's say the number is something like this, 4747. So I know this 7 can be made smaller. So at this position I can have one more choice. So this index is 0, and this will contribute 1 to my answer. This 4 cannot be made larger because we are finding out lucky numbers which are less than the number. Again, this 7 can be converted to 4, and if I do so, I will get how many extra numbers? So for these two positions, again I will have two choices and two choices. So this 7 will contribute 2 square to my answer, which is 4. So again this 4 will not contribute anything, so contribution due to 7s will be 5. So you can see there will be 5 4-digit lucky numbers in this case. So it will be 4 7 4 7, and if I change this 7, I will get 4 4 4 7 4 4 7 4 4 4 4 4 4 4 7 7. So these are the 4 numbers plus 1. So what is that number? So in this example, that number is 4744. So this is another number. So we know these 4 plus 1, 5 numbers are the 4-digit lucky numbers which are less than the current number, right? So you can say the final answer will be nothing but this is my answer 2. So this is my answer 2. So it will be 5 plus my answer 1. So in the answer 1, what I had done is I had removed the digits. So 4 7, what is the number? 4747. So if I talk about 3-digit numbers, they will be 8. If I talk about 2-digit numbers, they will be 4. If I talk about 1-digit number, they will be 2. So the final answer is going to be 5 plus 8 plus 4 plus 2. So this comes out to be 6, 14 and 19. So this is the 19th lucky number we have. So let's try the code also. Let us also try the code now. So in the code it is easy. So first I have to use this formula. I have to compute this thing, and then I have to see this thing. How many digits are 7? How many digits are 7 in the number? And for every 7, I have to add its contribution. So I can say the contribution of 7 will be 2 raised to the power position of the 7. So this is the contribution of 7. 2 raised to the power position, and these positions are numbered like this: 0 1 2 3. So let's start the coding part. So I am taking this number as an array of 20 digits, I'm taking this in as input. Then I'm going to compute the length of the array using the inbuilt function, and let's say our initial answer is 0. Let's also include the C string file, and now I know, if I know the length, the final answer is nothing but this plus this, right? So this can be written like this thing. So 2 into 2 raised to the power x minus 1 minus 1, right? And 2 minus 1 is 1. So if I open the brackets, I will get 2 raised to the power x minus 2, where x is the length of the number or the array, right? So my answer is going to be 2 raised to the power means 1 left shift length and minus 2. Then after that I can say, I can iterate over the number. I can iterate over the number from units place and add the contribution of 7. So for int I equals to length minus 1 till I is greater than equal to 0, I minus minus, and I can check if the digit is, if the current digits is equal to 7. So this 7 gives me more opportunities, gives me more lucky numbers, so I can add something to my answer. So I can add 1 left shift something. So this is the position of the 7. So this position can be again started from 0. We can initialize this position from 0, and I can say till, yeah, I minus minus and position plus plus. So what is happening, let me take example also. So 4 7 4 7, right? So this position is 0. I'm going to this position. This is 4. I skip. I come to next. This is the second position, first position, and third position. For this position, I'm adding 1 left shift 0, which is 1, and for this position, I'm adding 1 left shift 2, which is 4. Right? Because if I change this 7 by 4, if I change this 7 by 4, I get 2 options at this place, 2 options at this place. So I can make 4 more lucky numbers which are less than the current number. That's why I'm adding the contribution of 7 to my final answer, right? And finally, when you have figured out how many lucky numbers, so answer denotes number of numbers which are less than current number, right? So the position of the current number will be nothing but, so position of current number will be nothing but answer plus 1, because this value is storing the number of numbers which are actually less. So if I say there are 4 numbers less than 5, so what is the position of 5? It is nothing but the 4 plus 1. Yeah, so same goes here. So we can say the final position of the number is answer plus 1. So let's run it for a few cases. Yeah, so it should not be a colon here. So let me give input. Let's try for 4. 4 is the first number. All right, what about 47? It is the fourth number, which is correct. What about 77? Yes, it is the sixth number. All right, what about 4747? It is the 20th number. All right, so here we have had figured out there are 19 numbers which are less than the current number, so position of the current number is 20. The position of current number is 20, right? So let's also submit it over Codeforces. Yeah, so problem is this. So you can see this code passes all the test cases. So thank you for watching. I hope you like this tutorial.